The notes for this video are in the description box below. So today we're going to be doing the topic of sets. Now, what are sets basically? Sets, you could say, are a collection of different things, okay? Collection of things. Like basically this is the most basic definition of it. Collection of things, okay? For example, let's say you have the numbers 1, 2, 3, 4. Okay, a set could be made for, erase this. A set could be made for even numbers, right? You could have 2 and 4 in that set. You could have also another set of odd numbers where you could have 1 and 3. You could have a set, you could say, of prime numbers where you would have 2, 3. Okay, so you can have different sets. So universal set is basically all the numbers that you have, then you make sets from those numbers. Like we had the universal set here, 1, 2, 3, 4. Okay, and we made small sets, that is set A, set B, set C. We can make different types of sets depending on what is the criteria of that set. Okay, for example, each set has a criteria, meaning you have to pass this criteria to be part of this set, and the criteria you decide, or the questionnaire gives you the criteria. For example, in this case, you had the criteria, let's say, of even numbers. You could have 2 and 4. You cannot have 1 and 3 because those don't fit the criteria. So the criteria could be different depending on what the set you make or the set the questionnaire gives you. Now you also have something known as set notation. What does that mean? Set notation is basically the types of symbols that you have in your, you could say, the topic of sets. Okay, I'm going to explain all those different types. The first one, as I explained before, is universal set. The universal set has this symbol. Okay, universal set. Yep. Now, what is this? Universal set is basically the total numbers you have. Okay, as in the example I showed you above, that you had 1, 2, 3, 4. Those were your, you could say, your universal set. Then you made your small sets, like set A, where we had even numbers, set B, odd numbers, set C, prime numbers, composite numbers, different types of numbers. Okay, but that the beginning one, the 1, 2, 3, 4, was our universal set that we can use to make different types of sets from it. Okay, that's what universal set basically is. Now, second thing is this sign. You could say U, yeah. This means union. I'm going to explain what that means as well. Union, and we're going to explain this in, you could say, full detail when you go to Venn diagrams. In union, you should basically see it's adding two things, or you should be adding two sets. Okay, like let's say I have set A and I have set B. First, let me write the definition for it. Yeah, adding sets. Okay, for example, A, meaning the set A, union set B. What does this mean? Everything in set A, okay, let's say set A had the numbers 1 and 2. Okay, 1 and 2. Let's say set A had 1 and 2. And one more thing, that sets are written, make sure you write this over here as well. Sets are written with this curly bracket. Okay, so let's say set A had this and set B had, let's say, 3 and 4. Okay, so A union B would be, they're going to first make the curly bracket again, 1, 2, 3, 4. So all the numbers in A and all the numbers in B. Okay, so you add them. And then I'm going to also write this point over here. Sets are written in curly brackets. Okay. Oh. Then you have the next one, that is this sign, an upside down U. Now what does this mean? This means intersection. Okay, so, and if you want to understand this, basically this is, you could say, the common thing in sets. Okay, common thing in sets. What's in both sets? Okay, for example, A, set A, intersection B, and make sure to keep a close eye if this is a straight U or an upside down U, because this is going to change the entire answer. For example, in set A you have, oh, the same thing, 1 and 2, and in set B you have, let's say, 2 and just 2, let's say just 2. Okay, let's say maybe 3. Now what would be the common thing? 2. Yep, the only thing common in them is 2. That's it. So we're just going to write 2. Now you see that in union we took the you could say adding them together. So 1, 2, 3, 4, put all of them together. That means A and B, whatever in A and what's in B. A intersection B means A, okay, A has this, and what's common in A that also B has. Okay, so A has 1 and 2, B has 2 and 3. So A has 2, B has 2. So we're going to write 2. The next one that you have is this sign, and this means basically such that. Okay, and it's very self-explanatory, meaning, and these are going to be used, all the signs that I'm teaching you, these signs are going to be used to give you the question. For example, let's say if someone knows, let's say, English, and they've been given a paper in Spanish, they have to read the Spanish and then try to figure out what the question is, right? So same thing here. You could say sets is a different language, that you're going to be given this, all different types of notations, all the different symbols, and you have to find out, okay, what's the questions asking me? What is it asking me? Okay, you're going to find that. Now you have this, that means such that. Okay, for example, an example of this would be, let's say set A, you make this, is X such that, set A is X such that, so X is 1, 2, 3, 4. This is set A. Okay, so basically that would be a way of representing or way of using these two dots. Okay, now the next one you have is this one, N A, basically meaning number of elements in A. Okay, elements basically meaning the amount of things. For example, in this one you have 1, 2, 3, 4 elements. Okay, 1, 2, 3, and 4, you have 4 elements. In this one over here you have 2 elements. In this one over here you also have 2 elements. So elements basically means the amount of numbers or amount of things that you have in a set. Okay, that means number of elements in A. Number of elements in A, and this could be B, C, D, any set. Okay, this is just an example with A. Next one that we have is our complement. Okay, I'm going to explain what that means. For example, A complement, okay, or the set notation for this would be this, A with a comma on the top. You will have this written as the complement. So this will be the complement. Okay, so A complement means everything not in A, not in the set A. Okay, so if it's A complement, everything that's not in set A. If it's B complement, everything not in set B. but this will be the set notation. Okay, like over here you had the symbol NA, meaning number of elements. The set notation, or you could say the symbol for complement, would be this one, A complement. Okay, now the next one that you have is this one, this O, then you have a slash next to it. This would mean a empty set. Okay, for example, a set has nothing, like no elements at all, nothing at all. That will be this. You're gonna say that that set would be empty, but if you want to write it as a symbol, you can write this. Okay, that's the empty set. Then next you're gonna have this one, this sign of E. This would mean belongs to. Okay, belongs to. For example, A belongs, or let's say not A, let's take another example. Let's say that let's say 3 belongs to A, meaning the number 3 belongs to the set A. So simply you can use it like that. But now you may ask, sir, you also wrote an E before, like the universal set. What's the difference? I'm going to tell you. Because this E and the one at the top looks very much alike. And let me actually fix this one here. Yeah. This one will be something like this. Okay, it will be something like this. This will be a universal set, and you're going to have it written on the top of, you could say, every Venn diagram. I'm going to explain that as well, where you're going to have that universal set written. But basically, this is the difference. You're going to have the universal set symbol something like this. Okay, you could say a fancy E. Okay, and the belongs you sign like a normal, you could say E, like not a normal E, but like you can say a C, and then you make a line in the middle. Okay, but you're going to be able to identify the difference very easily. The next one that we have is our C, actual C. Now, C basically means subset. Okay, subset. Now, what is a subset? Meaning, you could say, for example, B is a subset of A, meaning everything in B is in set A. Everything in set B is in set A. So let's say if set B was, let's say set B had 2, 4, 6, and set A had 2, 4, 5, 6. Okay, that means set A has everything that set B has. So we're going to say B is a subset of A. Okay, the last one is very easy. Last one is the exact opposite, C slash, and you guessed it, not a subset of. Okay, so if they ever ask you, is this set a subset of so and so set, you're going to first check it, okay, with the criteria I just showed you. If not, then you're going to say no, it is not a subset of that given set. Now let's see some examples of the thing that we've learned. Now let's say, if you take the ink pen here, yeah, let's say, for example, we have the set A equals to, remember the curly brackets, is X. So set A is X such that X is, you could say, an even number or could say between 1 and 10, curly bracket closed. So we're going to have A as, again this, you can have it as 2, 4, 6, 8, between. Okay, you're not going to have 10, so you're going to have 2, 4, 6, 8. You're going to close the bracket and done. Simple as that. Okay, another example, let's take one more. Yeah, let's say if I have set B such that, so X such that X is, you could say, cars I know. Okay, cars that I know of. Okay, so we could say that set B is, let's say, I would say a Ferrari. Okay, I don't know much about cars, but still, let's try to write as many as we can. Let's say a Porsche. Okay. Let's say a Lamborghini. I don't know how to spell it, but you get my point. So basically, if we have a set, we're gonna write everything that we know about that set. Okay, so it's even number, we write even numbers between 1 and 10. Cars, I know, I don't know much, but still, we're gonna write this many cars. Okay, but this was just an example to show you how different types of things can become. So basically, this is just an example to show you that how sets are written. So you have to know the language of sets, you have to know the set notation to understand that. Okay.